I was just speaking with a customer and explaining thermal output. What are the consequences of thermal output?
Well, Kevin, that's an excellent question. It's probably one of the more misunderstood characteristics of strain gauges. Here we have a couple of gauges bonded to an aluminum specimen, and the thermal output from the gauge is simply its response to nothing but temperature. So if we have this free aluminum beam sitting on the table, and we make a measurement of the current output of that gauge, then if we grab this beam and hold it with our hands, we'll warm it up by the heat of our bodies, and the gauges will change resistance slightly, so the output's going to slightly change. So that's the definition of thermal output. Now the misunderstood part is that people think thermal output is a serious error of strain gauges, electrical resistance strain gauges. But in fact, it can be used to your advantage, and as most often is used to your advantage. For example, what if you had a sensor that had no thermal output correction inherent to it? For example, just a steel rule. So the steel rule just reports whatever measurement between two marks. If you heat that steel rule up, those distance between those marks is going to change. But the strain gauge has a wonderful property called self-temperature compensation. And what the self-temperature compensation attempts to do is remove all free expansion of the specimen, like when I grab the specimen with my hand, so that that's not reported in the measurement, because it's not important to the stress analyst. This guy that's designing a part using this aluminum beam typically doesn't care about the free expansion due to temperature. He only cares about the change in deformation due to load. So the self-temperature compensated gauges will remove almost all of that component of the measurement, that self-free expansion. Now, for example, if we grab this beam and we heat it up with our hands to close to 100 degrees F, then the beam's going to expand on its own by, fractions of an inch. But the strain involved in that could be 300-400 microstrain, going from room temperature to say 100 degrees F. The strain gauges, self-temperature compensated strain gauges, when used on this beam, will report only a very small microstrain output due to that temperature excursion. So that's the benefit, that's the consequence of self-temperature compensation and strain gauge thermal output, the ability to match the performance of the gauge to the material that it's intended to be used on.